Welcome listeners. Here we have again gathered to discuss the second part of our previous lecture on the origin of solar system, and I am Dr. Shayandi Banerjee, a faculty member in the Department of Geology, Banaras Hindu University, Varanasi. So, we will be continuing our discussion on the origin of solar system. Like we have seen the birth of a star in our first lecture during when we discussed about the origin of the universe, followed by when we discussed about cosmic dust, and from this cosmic dust the first initial planetesimals are forming, and finally how the planets are forming and which are the most important you can say features or you can say the set of planets that are present in our own solar system, because that is possibly the most till now that is the most you can say most important or most fascinating example of the presence of planets around a specific star, or the like we term the presence or the formation of a solar system. So we have taken our own solar system and as an example, and we have looked into the terrestrial planets, some characters of the Jovian planets. But again, to mention again that the terrestrial planets that are present relatively closer to the sun, they are denser in nature, and the Jovian planets are relatively lighter or less denser in comparison to the terrestrial ones. And there is obviously there is a quantification that is available for your terrestrial planets. The density will be more than 3 grams per centimeter cube, as well as in case of your Jovian planets, the density will be more than 2 grams per centimeter cube. So now, apart from the discussion of planets, we have also looked into the asteroids. Now it's time that we look into another important feature in our solar system, is the presence of meteorites and obviously comets. So the two astronomers, the first one, Fred Lawrence Whipple, he proposed the concept of dirty snowball model of cometary structure in 1950, and he suggested that comets are icy bodies with rocky debris that are mixed within a comet, and explained the phenomenon observed in comets, including the formation of the tail. So here you can see the movement of a comet like this, and you are having a large tail that is lagging behind the frontal part of the comet. So we'll have also a detailed discussion on how these tails are forming. Apart from that, another Belgian astronomer, John Hendrik Oort, he proposed the concept of the Oort cloud in 1950 to explain the source of the long period comets. He also demonstrated with evidence for the existence of dark matter through his work on the motion of stars near the sun, and contributed to our understanding of the rotation of the Milky Way galaxy. And he also pioneered the research on the distribution of matter within the Milky Way galaxy. So here you can see this diagram. It shows this is our solar system, and this is the, you can say, the enlarged view at the center of the solar system, where you have the sun surrounded by the different terrestrial and Jovian planets, and then you have the Kuiper belt, which is about 30 to 50 astronomical units away from the sun. Then apart from that, at the edge or at the fringe of our solar system, or actually a relatively outer part of the solar system, there occurs a large cloud of cosmic materials, that is the Oort cloud, which is around 5,000 to 10,000 astronomical unit away from the center of our solar system, that is our sun. So you have this presence of Kuiper belt as well as the presence of the Oort cloud that is present far beyond our you can say the outer part of the solar system. So it is believed that these comets are coming from this Oort cloud, and they come and again they revolve around our sun as well as our solar system, and they again finally go back to the Oort cloud. But before the discussion on the movement of the comets, we need to know about meteorites as well. So your solid fragments of asteroids. We have dealt with asteroids that are present in a belt that is orbiting around the sun between the orbits of Mars and Jupiter, and we have also discussed about the two possible processes that how these asteroid belts have formed. So, from these asteroid belts, there are solid fragments of asteroids, comets or meteoroids that survive their passage through the Earth atmosphere and land on the surface of the Earth. That's why they are called meteorites. So, basically meteorites are classified into three main types: stony meteorites, iron meteorites and stony iron meteorites based on their composition, and they also provide valuable information about the early solar system formation as well as evolution. And obviously studying meteorites are very helpful because they help us to understand the composition and history of asteroids and other celestial bodies. And finally, obviously there are several impact events, like we have seen the impact crater in Arizona, or the impact at crater that turned into a lake, that is the Lonar crater in Maharashtra. We have seen examples of it. So they do have significant geological and biological consequences on Earth. So we will also look at the biological consequences when we will be talking about geological time scale and the periods of different mass extinctions related to the impact of meteorites. There are three terms that are generally used along with meteorites, that are meteoroid, meteor and meteorite. So the difference is that the meteoroid are nothing but small rocky or icy object in space, ranging in size from a small grain of sand to a large boulder. Meteoroids originate obviously from asteroid or comets or collisions of larger celestial bodies. On the other hand, meteor, when a meteoroid enters, now it's a matter of, actually what we are looking here is a matter of location. So your meteor, when a meteoroid enters the Earth's atmosphere, it heats up due to friction and definitely it begins to glow. The glowing streak of light across the sky is called a meteor, commonly known as, we say, shooting star, and we generally wish after looking into a shooting star. It is nothing but a meteor. Finally, when it finally lands onto the surface of the Earth, again like I was saying, it's actually a matter of location, that whether we will refer it as a meteoroid, will refer it as a meteor, or finally we refer it as a meteorite. If a meteoroid is large enough and survives its fiery passage through the Earth's atmosphere and it can finally reach the ground and impact on the ground, then that meteoroid that lands on the surface of the Earth creating impact or craters will be now termed as meteorite. Talking about the different types of meteorites, you have stony meteorites, that is the most common out of all the meteorites that have fallen on the Earth. So 95% of all the meteorites are stony in nature, and they are mainly composed of silicate minerals. We will be dealing with the type of minerals in for example 3 or 4 lectures from now. And they can be also divided into chondrites and achondrites. So chondrites, they contain chondrules, which represent millimeter size spherical bodies which form during formation of solar system at around 4.5 to 4.6 billion years. And they also represent the undifferentiated primitive melt, and also they are the most abundant types of stony meteorites. Then you also have achondrites, which are stony meteorites composed of silicates but experienced familiar geological processes of melting and differentiation, and most of them formed during the formation of solar system, but a few were also formed during the formation of Mars and the Moon. So looking at a different category of meteorites that are classified as iron meteorites. So as the name suggests, they are composed of iron and nickel and are extremely dense. Then they represent actually the cores of the asteroid, and sometimes there is a very beautiful structure exhibited by these iron meteorites, which are known as Windman-Staten pattern, texture or structure. So Windman-Staten texture, they form due to the intergrowth of two different iron nickel minerals during very slow cooling. Also, they are referred to as Thomson structures. Then you have the different category of meteorites, that is stony iron meteorites, but these are extremely rare in occurrence. So, around less than 2% of all known meteorites are only stony iron in composition. So, they contain equal proportion of metal and stones, or that refers to silicate minerals. That means metals and silicate materials have combined to form this stony iron meteorites, and they have been formed in places where metal and silicates might have been mixed. So, this diagram specifically gives you the idea of the Windman's Saturn structure, like this, these triangular structures, and this you can say the presence of both stones and metals within this meteorite. So, that is why they are referred to as stony iron meteorites. Then finally coming into your comets. So, now comets are nothing but these are celestial bodies composed of mainly ice, dust and rocky material, often referred to as your dirty snowballs. Definitely they are formed in the outer regions of the solar system, and primarily they consist of the ice and dust. Now again, if I refer to the original concept of the solar wind, so you can see that the lightest material or the least dense material, they are present still they are present in the outer edge of the solar system. So, when comets approach the sun, they develop a glowing tail or coma due to the sublimation of volatile materials. So, they are again classified into short period and long period comets based on their orbital periods. And studying comets, because they are the initial, they also represent the initial, you can say, cosmic particles that have formed from the cosmic dust during the initiation of the formation of the solar system. So, studying comets provides insights into the early solar system condition and origin of water and organic molecules on Earth, because these comets are mainly frozen, sometimes frozen water or ice, and obviously some dust particles are there. So, the study of comets helps astronomers as well as us, the geologists, understand the dynamics of the solar system and its evolution over the time. Now, we will look for the reason that why there is a common question that why comets have tails, or to be specific, do they always have a tail? The answer is no, they do not always have a tail, because first of all, these comets possibly they are coming from the Kuiper belt or they are coming from the Oort cloud. So, they are traveling a very huge distance over a long period of time, because you can say that the Oort cloud is around, you can say 10,000 astronomical unit away from the sun. So, a body or a celestial body composed of frozen ice and dust particle that is traveling from the Oort cloud towards the sun, and again it is orbiting around the sun and again going back to the cloud. So, it is having a very large path, but during its travel, what is happening when it is coming possibly towards the sun, what is happening again, it is under the influence of the solar wind from our own sun. So, what is happening that the frontal part, which is relatively obviously the denser part of the comet, or which is the main core of the comet, that start to, due to the influence of the solar wind, what is happening that the materials that are attached to that core of the comet, they go into some kind of flame, or they form the tail under the action of the solar wind. So, again what is happening that the more dense material will be present on the head of the comet, and relatively lesser dense materials will get away or get disintegrated from the core of the comet, and they will form the tail. But it happens only and only when it is coming very close to the sun. So, this is an example of a comet path. So, it is coming towards the sun, and you can see the generation of the tail. The tail is continuously going larger and larger as it is approaching the center of our solar system, that is the sun. And again when it is going out or going away from the sun, the tail is again uh, decreasing. So the means you can say the frontal part means the part that is towards the sun will not have any tail, but the back side of the comet will always have a tail because of the burning of this, you can say, the energy or the energy that is getting emitted from the comet in form of electrons or bundles of electrons due to the action of the solar wind. So that's how comets always have a tail on its back. But remember, when it again goes out more or less away from the orbit of the Jupiter, it loses again its tail. So finally you can say that a comet will only possess a tail till it is very near to the sun, or it is within you can say the asteroid belt, because just after Jupiter you have the asteroid belt, then you have Mars. So once the comet enters the orbit of the Jupiter or crosses the orbit of the Jupiter towards its movement to the sun, in that case it will have a tail. Again, after orbiting around the sun, when it is going out towards the edge of the solar system, again it loses its tail. So that's how comets always possess a tail. Again, nearer to the sun, away from the sun, there are no tail of any comet. Okay, so after our discussion on comets, just to summarize about what we have learned through the origin of the universe and the origin of the solar system, just to summarize, then again we'll see that the history of the universe start from the beginning, and we have looked that where we are existing or where we are placed within the universe, and how there are processes like the process of the Big Crunch, which is just the inverse of the Big Bang, from where it all originated from, and likewise we also have or there could be a process of Big Crunch where your universe will finally end, but it will continue like as a cycle, as also proposed by Georges Lemaitre, the Belgian astronomer, like we have discussed. And likewise, so the beginning of the universe will start from the primeval atom, as well as the end of the universe will also be the achievement of that primeval atom through a cyclic process, and this process will go on and on over the time. For example, across a time span of 100 or a couple of 100 billion years. So apart from that, we have also looked at the origin of the galaxies, that how galaxies have formed over the time, how your hydrogen atoms got modified into helium atoms, and finally how this cosmic dust and these particles, they have coagulated over the time, forming a disc shape, that is your galaxy. And also our presence in that one of the galaxy which is referred to as our own Milky Way galaxy. It is commonly in India also known as Akash Ganga. So that Milky Way galaxy, we are present in the edge or far away from the center of the Milky Way galaxy, and that is I'll say kind of we are fortunate that we are far away from the center of the Milky Way galaxy, because otherwise if we had been at the center or near to the center of the Milky Way galaxy, it would have been hard to look into beyond the Milky Way galaxy. But simply, for example, if you are standing on the fringe of a forest, you can look at the whole forest and also the unforested area which are associated with it. But if you are at the center of a forest, you can't really see around you, there will be only woods around you, so you can't see beyond that. So based on the same concept, we can say that as we are sitting or we are present on the outer edge of the Milky Way galaxy, we can look at the other galaxies, for example the Andromeda galaxy, which is around 2.5 million light years away from us. Then we also discussed about the life cycle of a star. So again, just to look at the life cycle, so from this nebula where you have this dense region in nebula, it begins to shrink. it becomes warm, and then it becomes a protostar, which is obviously the initiation of a star. Then it forms a main sequence star where your nuclear or your thermonuclear reactions are going on inside, and it obviously produces light and heat, as we know. Then it can be again, the fate of a main sequence star can and be divided into two parts. The first, the formation of supergiants, where the star of a greater mass expands, cools, and finally turns red. And obviously the fate of that supergiant will be a supergiant explosion, or what we call as a supernova, where your outer layers will be blasted away and only the core of that star will remain, and even sometimes the core might collapse and becomes very dense, like we get to see in a neutron star. Then also the other possibility is that the core collapses and completely vanishes, and what we now refer to as the black hole. Still we don't know much about black holes, but this is the possibility how a black hole might have formed. Then the other fate of the main sequence star is the formation of a red giant, where obviously the star is of relatively less mass, it expands and glows, and eventually it cools down, and the outer layers of gas, it simply gets you can say puff off, and the hot core will be exposed as a white dwarf. And also the final fate of a white dwarf will be the star will cool down, and finally it will stop glowing like it used to be in the stage of a red giant, and finally what will become as a black dwarf. So, and again to remind you that all the elements that we get to see on the periodic table till your atomic number 92, means from starting from hydrogen to uranium, all these natural elements, they are a result of the supernova explosion. And also as we speak, the presence of carbon, human being, as well as in every living means animal, as well as the presence of oxygen, be it in plants or be it any living animal, is also a result of the supernova. So here I would also like to mention a thing, that in our chemistry classes, be it in our school life or be it in my undergraduate course, no one taught us about from where these elements actually evolved. So the only thing that could result into the evolution of these elements is a supernova. We have read about every element in the periodic table, but no one told us never that what is the origin of these elements on the earth. So the answer is only one: the result of a supernova explosion will give you this element, starting from the first natural element, that is hydrogen, to the 92nd one, that is uranium. And also we have discussed about the cosmic dust, like these are obviously the pillars of creation, and this is a simple photograph from the nebula Hubble telescope, taken from the Hubble telescope. It is the a photograph of Keyhole Nebula, and if I look at the cosmic dust or a particle of cosmic dust under scanning electron microscope, then it will look like something like this. There are very tiny particles, but all these are the results of a supernova explosion. Then we talked about the formation of the planetesimal and resulting into the formation of the planets. So from where your cosmic dust, they due to the presence of the eddy currents, they coagulate with time under the action of gravity, and finally they rotate and form a disc-shaped structure with the main star sitting at the center of the disc-shaped cloud, and then finally the consolidation of other cosmic dust resulted into the formation of the protoplanets, followed by the formation of the planets. And we have also looked at how our solar system might have formed, and these are the different planets. As we know till now, there could be some more inventions in or discovery in future, but till now we have these 4 terrestrial planets which are relatively same in their density, and you have also Jovian planets, though there is a variation in their size, but more or less the density of the again Jovian planets or the gaseous or the giant planets, they have relatively less density in comparison to the terrestrial planets. Then we have also discussed about asteroids, like we get to see the impacts of asteroid, and also from the presence of the asteroid belt between the orbits of Mars and Jupiter, and also from the belt that we refer to as the Kuiper belt, there are always movements of asteroid in and out of our solar system. And likewise, the result when say an asteroid or a meteoroid that finally reaches the surface of the earth, then we refer it as a meteorite. And obviously these meteorites, they have been classified into, like we have discussed, have been classified into stony iron and stony iron meteorites, and each of them represent some parts of our own earth. Like for the example of stony meteorites, which are silicate, which are dominated by silicate minerals, which are constituted by silicate minerals. Similarly, like as we get to see on earth, our rocks that are occurring on the surface of the earth, they are again dominantly constituted of your silicate minerals. Apart from that, you have iron meteorites as well as stony iron meteorites, which are relatively less in number. But talking about the impact of the asteroids, which are the result which is the main reason of the formation of impact craters. There are several impact craters, and we have discussed also that why we get to see several craters on the moon or even on Mars, the surface of the Mars, but we don't get to see so much number of craters on the surface of the earth. The main reason is obviously the presence of the oceans, and the relatively 30% only area is being occupied by the land masses. So there obviously the probability of hitting of a meteorite is less in comparison to your moon and Mars. So likewise, there are craters in the land surfaces, and sometimes these craters are also filled up at places with water, like we get to see a brilliant example of an impact crater lake in our state of Maharashtra, that is Lonar Lake. And due to the advent of recent technologies, we have now been able to recognize some more craters in different parts of the earth by the application of your aerial images as well as satellite images. So finally, I would like to remind you that obviously we have looked into the origin of the universe and looked into the origin of the solar system, but remember, these are much more complex and complicated subjects which need special attention from on the science of, you can say, astronomy, or can be explained with the help of different physical concepts like we have learned in our school days under physics, and also some higher level concepts dealing with physics. So here what we have discussed is mainly we have looked into the perspective from a geologist, or we have looked into the universe as well as into the solar system from a geological perspective. So we will be discussing continental drift and plate tectonics in our next lectures. Thank you.